Hello, this is Tyagarajan. In this video, I am going to discuss how to answer multiple choice questions in computer architecture and organization. I have also given the answers with short explanation. If you have not subscribed to my channel, please press subscribe button and also click on the bell icon and choose the option all. In this video, I am going to discuss the modified Booth's algorithm, which is also called as bit pair recoding, and I will also discuss what type of multiple choice questions may be asked from this topic. They may ask 1 mark multiple choice question or 2 marks multiple choice questions from this topic. This bit pair recoding speeds up the multiplication process and reduces the number of summands to half. Bit pair recoding is a modified Booth's multiplication algorithm. The recoding is applied only to the multiplier as we did in the Booth's multiplication algorithm. Here also, same number of bits are used to represent the multiplicand and multiplier by adding zeros in the left side. If the multiplier is negative, take 2's complement including the extra bit added. Before recoding, add 1 extra bit at the rightmost position. While recoding, if necessary, extend the sign bit on the left side. That is, if the MSB is 1, you can add 1s in the leftmost position. If MSB is 0, you add zeros in the leftmost position. All the steps provided here are same as the steps provided for Booth's multiplication algorithm. The only difference is, while recoding, instead of using 2-bit table, we will be using this 3-bit table. In this table, 3 bits are combined to provide a recorded value. If the 3 bits are 0, 0, 0, the recorded value will be 0. If the bits are 0, 0, 1, then the recorded value will be plus 1. If the bits are 0, 1, 0, the recorded value will be plus 1. If the bits are 0, 1, 1, the recorded value will be plus 2. If the bits are 1, 0, 0, it will be minus 2. Now, if you compare the top 4 values, the same values are repeated here, but it is just like a mirror image of that. Here you have plus 2, here you have minus 2. Here you have plus 1, here you are having minus 1. Similarly, here plus 1, minus 1. This is the first 0, the last one is also 0. So if you put a line here, it is exactly the mirror image of that one, but instead of plus, you have to put minus. So if you remember this half, you can easily write the remaining half. Anyway, you have to remember this table to recode the multiplier using bit pair recoding. When the value given here is multiplied by the multiplicand, it produces partial product. Now let us see some questions in this topic. The partial products for rows 5 and 8 of the bit pair recoding table are, that is, this is row 1, 0, 0, 0, they have given it as 0, 0, 0, 1, instead of plus 1 they are giving y, 0, 1, 0, instead of plus 1 they are giving y. Then for 0, 1, 1, instead of giving plus 2 they are giving it as 2y. That means y is multiplier. Now 1, 0, 0, what will be the value? As I already told, if you remember these 4 values, the remaining 4 values you can get from these values itself. That means since here it is 2y, this is minus 2y. Then this is given, this is also given. Then the last value will be 0. So if you remember the table, you can directly give the answer. But anyway, let us see the options. In the first option, this is 2y and this is y. It is not correct. Actually, here you should get minus 2y. So, B is having minus 2y, but C is also having minus 2y. So, we have to decide whether B is correct or C is correct. Now, you compare this next value. This is 0. So, the next value is 0 here. So the C option is correct. That means here the value should be minus 2y and here the value should be 0. So C is the correct answer. Now let us see the next question. Shifting a binary number left by 2 positions is equal to multiplying the number by 2, multiplying that number by 4, dividing that number by 2, dividing that number by 4. If you shift one position, it will be equal to multiplying by 2. Since shift is done by 2 positions, it is equal to multiplying by 4. So the answer is B. Now let us see the next one. Shifting a binary number right by 2 positions is equal to multiplying that number by 2, multiplying that number by 4, dividing that number by 2, dividing that number by 4. Actually, if you shift right by 1 bit, it is equal to dividing by 2. Since we are shifting 2 bits right, it is equal to dividing by 4. So the correct answer is D. Let us see some more questions. The bit pair recorded representation for +3 is this one. Anyway, we have to solve. We have to actually find out the recorded value for +3. Then only we will be able to pick up the correct answer. Let us see how to do that. The number is 3. First you convert it to binary. So 3 is represented as 1 1 in binary form. For bit pair recoding, you need 2 zeros in the left side. So you put 2 zeros here, and when you try to record, you have to put 1 zero in the right side also. So like this. Add a 0 in the right side. Then use the table and encode it. The table is here. You have to remember this table. Encoding is done like this. These 3 bits are now combined 110. 110 means the recorded value is -1. Then these 3 bits are combined. To record this 1, you need 2 more zeros in the left side. That is why we added 2 zeros in the left side. Now all these things are combined 0, 0, 1. The recorded value will be +1. So the answer is like this. That is 110 is recorded as -1, 001 is recorded as +1. So the result is +1 -1 here. But anyway, you remember that this +1 should be put here. That is, you should leave one place here. So the actual value is, you can put any leading 0. So 0 +1, you have to put 0 here, -1. Bit pair recorded multiplier is a Radix-4 multiplier. That means the positional value for this first number, that is LSB, is 4 power 0, and the positional value of this second number is 4 power 1. So when these bits are used as multipliers, for the first bit you will get a summand. When the second bit of the multiplier is used, the summand should be shifted left by 2 bits. That is why it is Radix-4 multiplier. You can put 0 in this place, that is here. Then you can put 0 here also. So the recorded value is 0 + 1, 0 -1. 0 + 1, 0 -1. Correct answer is C. But in bit pair recoding, this 0 is not needed. But when you are multiplying by this number, the summand should be shifted left by 2 bits, not 1 bit. Now let us see the next question. The Radix-4 representation for +3 is A -1 + 1, B 0 + 2, C +1 -1, D 1 1. So the previous problem has been asked in a different way. So instead of putting a 0 between these 2 bits, a space has been provided. That means it is Radix-4 representation. That is, the positional value for this bit is 4 power 0, and for this bit is 4 power 1. So as we did in the previous problem, we can solve this and we can find that the answer is +1 -1. That is C. So the correct answer is C. But you can use a shortcut here. See, this is Radix-4 representation. Actually, it is the bit pair recoding. So the first bit value is 4 power 0, that is 1. The next bit value is 4 power 1, that means 4. So the second bit should be multiplied by 4. So the actual value for this combination is -4 + 1. That is -3. 3. In the second case, it is 0, then plus 2 into 1 is equal to 2. And in the third case, it is this is 4 into 1 or 1 into 4 plus minus 1 into 1. That means 4 minus 1, it is plus 3. In this case, it is 4 plus 1 is equal to 5. If you observe these values, C is representing 3. So in multiple choice question, if you want to find out the exact bit pair recoding of the given options, you can use this method and you can easily say that this represents 3. In the Booth's modified recoding or bit pair recoding or Radix-4 coding, we used 3 bits table. Now let us see what is the basic idea behind that. In Booth's recoding, let I be the bit to be recorded and I minus 1 is the bit right to the bit I. That is, this is I minus 1 is the bit right to that I. Now if you want to recode using Booth's algorithm, if both are 0, recorded value will be 0. If both are 1, recorded value will be 0. If it is 0, 1, the recorded value will be plus 1. If it is 1, 0, the recorded value will be minus 1. Here we have used only 2 bits, but in modified algorithm, we will use 3 bits. This is I plus 1, this is I minus 1. Now, if you want to record these 3 bits, first you take these 2 bits 0, 0, apply Booth's recoding algorithm here. 0, 0 means it should be recorded as 0. So this one 0. Now you take these 2 bits 0, 0 and that will be recorded as 0. Then in the next case 0, 1, 0, 1 means plus 1, it will be recorded as plus 1. Then these 2 bits 0, 0, it will be recorded as 0. This is 1, 0, it will be recorded as minus 1 and this 0, 1 will be recorded as 1 because 0, 1 is here plus 1. Similarly, for these 2 bits 1, 1, the recorded value is 0. For 0, 1, the recorded value is 1. Similarly, you can record all the combinations. These 3 bits have been recorded using Booth's algorithm as 2 bits. Now, the position value for this bit is 2 power 0 and for this bit is 2 power 1. Using these 2 position values, you compute the values for these bits and use it as modified value. So for 0, 0, the value is 0. For 0, 1, this position value is 1. So 1 into 1, 1 and here 0. So it will be plus 1. But in this case, this is minus 1. Here it is plus 2. Position value is 2. So 2 minus 1 is plus 1. Here, in this case, it is 0. Here 2. So plus 2. And in the next case, it is 0 and here it is 2 into minus 1, it is minus 2. And here it is 1, here minus 2 plus 1 is minus 1. And in this combination, value is minus 1 and here it is 0. So 0 minus 1 is minus 1 and here both are 0. So now 3 bits have been recorded by one single value. It is not a bit, it is a single value because you are getting plus 2 also, minus 2 also. So now you remember this procedure. That is, if a number is given, first you are applying Booth's recoding method and you are obtaining the bits. After that, you are combining 2 bits together and you are getting one single value. Instead of 2 bits, if you have 4 bits, you combine 2 sets of 2 bits. Now let us see another example for bit pair recoding or Radix-4 recoding. The Radix-4 recoding for plus 5 is A plus 1, 0, B plus 1 plus 1, C plus 1 minus 1, D plus 2 plus 2. In this case, first you have to convert this decimal number 5 to binary number. It is 101. You can use bit pair recoding table for recoding this plus 5, or you can start from the scratch. That is, you have to apply Booth's recoding first, then you have to apply modified Booth's recoding method. So if you want to apply Booth's recoding, first you put a 0 in the right side and also a 0 in the left side for sign. So 101, you put a 0 in the right side. If you apply Booth's recoding algorithm, these two bits will be combined and you will get -1, because this is bit I, this is bit I minus 1. If it is 1, 0, you will get -1. Then we have to combine these two bits. In this case, 0, 1. So the recorded value is +1. Next, you have to combine these two bits. It is 1, 0. So the recorded value will be -1. Now, this 1 should also be recorded. For that, you need a bit in the left side. So you put a 0 because this is +5. So the sign bit will be 0 here. So to record this 1, you have to add a 0 in the left side. Now 0, 1 will be recorded as +1. These 4 bits are the Booth's recorded value. To get modified Booth's recorded values or Radix-4 values, you have to pair these bits like this. These two bits should be paired and these two bits should be paired. These two bits should be combined by using their place values. For example, for this bit, place value is 2 power 0, and for this bit, the place value is 2 power 1. That means 2. So 2 minus 1 is +1. Similarly, here the place value is 2 for this bit and place value for this bit is 1. So 2 minus 1 is +1. Now, these are the Radix-4 values or bit pair recorded values. You can cross-check the recorded values. In the case of bit pair recoding or Radix-4 recoding, the position value for this bit is 4 power 0 and for this bit is 4 power 1. Now, you have +1 here, so the value here is +4. And you have +1 here and the value for this position is 1. So 1 into 1, it is 1. So +1 is equal to 5. So the recoding is correct. So the answer is +1 +1. That is, the correct answer is B. See, here also you can cross-check the Booth's recoding. Here, the position value is 2 power 0, 2 power 1, this is 2 power 2, and this is 2 power 3. That means this is 1, 2, 4, 8. So you have +8 here, then -4, then +2, then -1. So 8 minus 4, 4 plus 2, 6 minus 1 is equal to 5. So this Booth's recorded value is representing 5 and this bit pair recorded value is also representing 5. So without using the recoding table, we have computed the recorded values like this. This is the basic idea behind the table created, as I already explained. So this example shows how to use the basic idea of bit pair recoding. Instead of doing all these processes, you can directly guess the correct answer from the given options. This is only possible for MCQs. Since the options are given in Radix-4 form, you just compute the values for each option. That is, the position value for this bit is 4 power 0. The position value for this bit is 4 power 1. So here you have +1. So 4 power 1 is 4. So +1 into 4 is +4. Plus Here you have 0, so it will be 0. So it will be plus 4. In this case, you have plus 4. That is 1 is the value. The position value is 4. So 1 into 4 is plus 4. Then plus 1 into 1 is equal to plus 5. Then if you take the third option, this is plus 4. Then here minus 1 into 1 is minus 1 is equal to plus 3. Then here 2 into 4 is plus 8 because plus 2 into 4 is plus 8 plus 2 into 1 is 2. It will be plus 10. So if you see these values, this is giving the decimal value plus 5. So option B is the correct answer. Now let us see a different question. If the Booth's recorded multiplier is plus 1, minus 1, plus 1, minus 1, then the bit pair recorded multiplier is A plus 1, 0, B plus 1, plus 1, C plus 1, minus 1, D plus 2, plus 2. In this case, you may not directly apply the Booth recorded table because instead of giving the decimal number or binary number, they have given the recorded multiplier itself here. Now we have to convert this to bit pair recorded multiplier. So you have to pair these values like this. These two values should be combined to get the bit pair recorded value. Similarly, these two values should be combined to get the bit pair recorded multiplier. The position value of this number is 2 power 0. The position value of this number in the pair is 2 power 1. Similarly, the position value of this number is 2 power 0. The position value of this number in the pair is 2 power 1. Now, based on these position values, you have to combine these two bits. So, the value for this bit is 1 into 2. The value for this bit is minus 1 into 1. So, plus 2 minus 1, you will get plus 1. Similarly, here you have 1 into 2, the position value is 2, 1 into 2, 2, then minus 1 into 1, minus 1. So 2 minus 1 is plus 1. Now, these two values are the bit pair recorded value. And the position value of this first number is 4 power 0. Here the position value is 4 power 1. So this is also called as Radix-4 or bit pair recorded multiplier. So the correct answer is plus 1 plus 1. In the option, if you see, the correct answer is B, plus 1 plus 1. You can solve the problem like this and you can find out the correct answer, or you can follow this shortcut also. That is, you can also use position values to pick up the correct option if it is MCQ. So the given recorded multiplier is plus 1 minus 1 plus 1 minus 1. You write it here. The position value for this number is 2 power 0. For this number is 2 power 1. For this number it is 2 power 2. For this number it is 2 power 3. So 2 power 3 means 8. This is 4. This is 2. This is 1. So this will be equal to 1 into 8 plus 8. And this is minus 1 into 4. That is minus 4. This is plus 1 into 2. So plus 2, and this is minus 1 into 1, it is minus 1. So this will be equal to 8 minus 4 is 4 plus 2 6 minus 1, it is 5 plus 5. So the given recorded multiplier is plus 5. This indicates plus 5. Now you check bit pair recorded options. In the case of bit pair recorded values, this is having a place value of 4 power 0. This is having place value of 4 power 1. Now you solve this. This is 1 into 4. This is plus 4. This is 0. So you have plus 4. So option A represents plus 4. Now you take option B. This is 1 into 4, that is plus 4, plus 1 into 1. 4 power 0 is 1. So plus 1 is equal to plus 5. Now this one is option C, provides plus 1 into 4 is plus 4. Then minus 1 into 1 is minus 1 is equal to plus 3. Then this is 2 into 4 is 8, that is plus 8. Then this is 2 into 1 plus 2. 2 into 1 is 2. So this is plus 10. Now these four options represent these decimal values. Since the given recorded multiplier is 5, option B is also representing the same 5. Option B is correct. So you can use this shortcut also, but the classical method to be used is this one. Let us see the next question. The bit pair recorded representation for -6 is, options are given. You have to recode it. The step 1 is convert 6 to binary. Actually, this multiplier is negative. First, you convert 6 to binary. You will get 110, and you have to add 10 in the left side. But 10 is not sufficient because you should have these 3 bits to be combined. Then this bit and one more bit should be combined. So you have to add 2 zeros in the left side. Since the number is negative, take 2's complement of the number given in step 2. That is, you have to take 2's complement for 00110. First, you take 1's complement for this number. So that is 1. This 0 will become as 1. This 1 will become as 0. This 1 will become as 0. And this 0 will become as 1. So this is 1's complement. And add 1, you will get 2's complement. So the 2's complement is 11010. This will represent -6. So you have to recode this number. For recoding, you have to add 10 at the right side. So this is the number. You add a 0 at the right side, like this. Now you use the bit pair recoding table and recode this 100. Then 101 should be combined. Then 1 should be combined, but you need one more bit here. Since this is a negative number, you have to only extend the sign bit. So you may not put 0 here. You have to add only 1 here. Now you have to combine like this using the table. You see the table? So 100 is recorded as -2, and that -2 should be put here under this bit. Then the next one is 101. 101 is -1, and that value should be put at this place. That means you have to leave 1 bit position. Then next one is 111 is recorded as 0. So the recorded values are 0, -1, -2, but in between there is a gap. You have to put 0 here. I have brought this 0, -1, -2 here, 0, -1, -2, and you put 0 like this. So the recorded value is 0, 0, -1, 0, -2. D is having 0, 0, -1, 0, -2. So the correct answer is D. Let us see some more questions in this topic. In the bit pair recoded multiplication, the binary coded multiplicand is bit pair recoded. Both the multiplicand and the multiplier are bit pair recoded. Multiplier is bit pair recoded. Result is recoded. Actually, in the bit pair recoded multiplication, the binary coded multiplier is bit pair recoded. In Booth's algorithm, only multiplier is recoded, not multiplicand or not the result. So answer is C. Multiplier is bit pair recoded. I want to give some information to you. Converting decimal to binary is called as encoding. Converting binary to decimal is called as decoding. Converting the encoded binary to another new form is recoding. So Booth's algorithm is only recoding because the decimal value is encoded to binary, and from that binary again we are coding to some other form. So that is called as recoding. So you should know the difference between encoding, decoding and recoding. Now let us see another question. In the bit pair multiplication process, if the result obtained is 110110, then the decimal value of the result will be 238. We may not guess. We have to solve this. Let us see. Since here MSB is 1, the result is negative. So all these 3 ones indicate that it is a negative number and the sign has been extended. And the remaining bits will provide the magnitude since it is a negative result. Even you take 2's complement for all the bits, there will not be any difference. Now you see this is 0, 0, 0, 1, 0, 0, 1. This is the 1's complement of this value. And add 1 to get 2's complement. The 2's complement is 1 plus 1, 0, and there will be carry. That carry will be here. Then 0. This 0 will come here, 1, and remaining bits are zeros. So the 2's complement is this 1. Now what is the decimal value of this binary number? To get the decimal value, so you put 1, 2, 4, 8, 16, 32, 64, 128 like this. That is, in each position you are multiplying the previous value by 2. So 1, 2, it is multiplied by 2, 4, then 4 into 2, 8. 8 into 2, 16 like this. Now you put the binary bits here, that is 0 here, 1 here, 0 here, 0 here, 1 here, like that. Now to get the decimal value, here 1 is there, so 16, then here 1 is there, so 2. So 16 plus 2 is 18. So the value is 18. Since we have taken 2's complement, the actual value is minus 18. It is a negative number. So the magnitude is 18, but the actual value is minus 18, and the correct answer is C, minus 18. If you have not subscribed to my channel, please press subscribe button and also click on the bell icon and choose the option all.